Next up, we have Nenad Viterovic, who's DevRel at Tenderly. And Tenderly is an all-in-one Web3 development platform, everything from building, testing, upgrading, monitoring, and operating your smart contracts, taking you from launch to handling mass adoption. So today, Nenad will be discussing how to build better DApps with Tenderly and Moonbeam. So with that, I'll hand it over to you.
Thank you, Kevin. So hi, everybody. I'll just switch over. I don't know if my screen is shared. Yeah, about now it is. So I'll just start off with a very, very brief 3-slide PowerPoint presentation. And I'll, as Kevin nicely said and explained, Tenderly is a platform that gives you a bunch of tools and services that you as a developer can use to improve your developer experience. So to, work with Ethereum in a more accessible way and keep your sanity, but also improve the experience for your users that are using your DApps. So in that sense, we're talking about how you can use Tenderly tools to build better DApps. And first of all, I'll briefly talk about what I'm going to show today. So the first chapter is talking about how to test smart contracts using Tenderly forks. So this is something that can improve your development journey, so you can write better hard hat tests supported by tools in a really nice way. The second chapter would be how to improve the user experience of your dApps with Simulations API. And there you will see that I used to do some front end, but you will also see that I'm not the best front end engineer visually. And the third part is about building front end and improving actually the process of building front ends for the dApps using Tenderly forks. The last chapter is about the question, can you get better? And before I actually dig into all of this, and before I actually start showing how you can use these tools in the spirit of this being a workshop, hope everything works. I just want to briefly touch upon the fact that Tenderly has a bunch of tools that are working with EVM compatible networks. So whatever is EVM compatible, our tools can support it, if not fully, then to a very high degree. And I think this fits very well with the Moonbeam network, especially because in the following weeks, there will be a release of integration or support of Tenderly tools for the Moonbeam network. So, having said that, I will just try to categorize the tools that we have into 3 broad categories, and we'll go into those in a higher degree after I show you what you can do with them. So basically, we have one category which is about developing your smart contracts. So all the tools that you need to develop and troubleshoot your smart contracts and your DApp. So not only smart contracts, so you can build it with more confidence and greater speed in terms of feedback loops of what you're doing. The second thing that Tenderly has is observability. So our tools allow you not only to develop the thing, but also when it goes live, you can hook into everything that's going on with your DApp and be very much alert when something happens, so you can actually improve all of that, the entire process and the project you're building. And the third part is infrastructure 3.0. So it's about the direct access to the blockchain in the sense that you actually have Node as a service as a new part of things we're doing, but also there's Web3 actions that allow you to write your serverless backends for your smart contracts. Again, it's a bunch of tools that help you build and test and monitor your smart contracts, integrate them together, integrate them with external systems, and also operate them. And this is the briefest intro that gives hopefully enough context. And now let me switch to the Tenderly dashboards. So here The first thing we'll cover, if you remember the first slide, is actually testing of smart contracts and the tooling around that. So here I have a transaction that's a result of a test execution in Hardhat, and the transaction failed. So it says here that this transaction has insufficient number of confirmations. All right, but before actually digging in here and trying to figure out what's wrong, let's talk about the contract we're looking at. So the contract is, I'll show it in Visual Studio Code. The contract we're working with is a well-known multi-sig wallet, so it's sort of like off-the-shelf component right now. Of course, you have Gnosis Safe doing that stuff in an amazing way. And just for the newcomers in the crowd, a multi-sig wallet is a wallet that you can use with multiple other owners, and you submit transactions you want to execute and fund through that wallet. And the owners have to agree that, yes, we want to have this transaction executed. So the owners have to confirm, yes, let's execute this transaction. Of course, there is a minimum number of required confirmations. So when enough owners agree, one of the owners can actually execute the transaction, and then it actually reaches out and shows up on a network. So this is the contract we've been testing, and this is the, let me go back here. So this is this failed transaction. So it says that it's got insufficient confirmations. And in Tenderly, you can actually see, for example, the input data, and the input data is decoded. So this particular function, it gets a number practically, the index of that transaction in the array, the one that we wanted to execute. So let's go back here. And as you can see, we entered the debugger, something you're very used to from traditional technologies. And you'll notice that this require actually reverted, which means that, let me zoom in a bit, but now it's all crammed. All right, let's do it like this. So that means that this condition over here is false. And to make sure that's true and to explore why this happened, we could either go about this by getting storage slots for this particular smart contract field, or try to get this transaction object, which actually is an element in the array of the smart contracts field called transactions. So you can already see that it's too many moving parts. But the thing that we can do is copy this expression, open up evaluate, something, again, we're very much used to. Either it's a watch in JavaScript or the eval function in other tools. And by just entering it and clicking evaluate, you can see that, yes, we got the result of evaluating this, this expression. So let's examine it component by component. So let's see how many confirmations are required. And I hit evaluate again, and I get 2. So we know that this wallet is set up to have 2 confirmations that are needed, so transaction can execute. And here again, I will remove the second part, and I'll just keep what is the number of confirmation for this very transaction number 4. And when I hit evaluate, I get 2. So again, this means that this little piece actually has a logical issue in there. So we have 2 confirmations, 2 are required. So this thing actually contains a logical bug. And the solution is easy. Most of you might have seen it in the very beginning, that we just need to say greater than or equal to. But for the sake of troubleshooting process, let's see how we can verify that this is the solution. And the second step, how to apply the solution and see the test running. So to verify it, I could go back to the Visual Studio Code and I could edit this contract source, but I would need to run the entire test, and that would take time. So here, I'll just actually, I just want to see how would this transaction execute against the changed code. So I will just simply do a simulation. I'll click the resimulate button, and if it's confusing, we'll get to it soon. And I don't want to change anything. So I want all the parameters, and this might be an issue, all the parameters of the transaction to remain absolutely the same. I just want to change the contract source. And I want to go down here and go to, yeah, this is the one. So it says execute transaction. And this is the revert that failed. So you can think of this as hot swap. When you change the code, save it, and your debugger gets the updated version. Well, this is hot swap that you get with with Ethereum transactions. And I'll just hit apply changes. And when I hit simulate transaction again, we have to wait for a moment, and then we get a success flag. So we debugged it, we found where the bug is, and we also verified that this solution works. And it took us really not that much time. So before we actually apply this fix in our code base, let's just give a little bit of attention to this word over here that says simulated. So this transaction doesn't actually come from a network. It comes from a fork. So what is a fork? You can think of it as a lightweight, virtualized sort of network. Here you can see that we made a fork from Goerli at this block. And you can think of a fork as network that's, it's a network that got free from the consensus layer. You only have the execution engine, and of course you have something to remember all the transactions you executed. And that's why all these simulations run pretty fast when you do them. But it behaves like a network, and it looks like a network. It behaves like a network because it accepts transactions. It looks like a network because it exposes an RPC URL. So wherever you can use or connect to a network, you can also connect to a fork. That can be your hardhat config, that can be your MetaMask, one of your MetaMask networks, that can be your front-end code, it can be whatever you like. And this is why it's useful for running tests. Now let's come back to the test itself, and let's apply the fix that we found just now. So here's the execute transaction, and it should have greater than or equal to sign. And here I will just run npx hardhat test network tenderly. Now network tenderly, this is the crucial bit. We have to wire our tests to use the tenderly network. And to do so, the only thing we need to do is to open up, let me zoom out a bit and let me hide this Goerli config. So in the hardhat networks, we add tenderly, we set a particular chain ID, and we set the tenderly fork URL. Of course, I'm keeping this in an environment file, so I don't I don't leak these out. But this is the only thing you have to do to allow hardhat to use tenderly as a network for tests. So when I run this, you'll see that the test is running, and it says that it's actually deploying multisig wallet. So the test deploys the contract that we're testing in here, and also runs like 6 tests, each of them having several transactions going on, and all of this happened in 12 seconds. And we can see that our test passed. And we can come back to tenderly, and I will reload this page, and you will see, let's just wait for a moment. You will see a whole lot of invocations happening here, and that's all coming from this latest test. I will find it. Yeah, so this was like the latest one that we did before running the test suite, and these are all the transactions that happened in between. And that's how you can use tenderly forks to give you better tools for running your tests, but also when your tests fail, you immediately have all the tools that you need to debug them, to analyze what happened to them, to figure out what the bugs were, to validate how to solve those bugs, and again, to restart the whole testing cycle hoping you'll get some sanity in the development process. All right, so that's Tenderly and Forks. And now this is, as I said, let me go back to this slide. The second chapter would be how to improve the user experience with Simulations API. So this first thing was about improving developer experience, making your life, move in a better pace. I don't want to say faster. But the second thing is how to improve user experience with Simulations API. And to demonstrate this, I will switch over to my browser. Let me just move this thing. Yeah, I'm going to switch over to my browser. And here I have this state-of-the-art multi-sig front end that I built. So you can see it's not very pretty, but it'll do the trick. So again, picking up from the intro and the previous example, this would be the front end for your multi-sig. So you want to send a transaction from this address. Now, this is a gimmick example. It's not a good practice. To this address with this value, and you want to send it with this data to practically invoke this function. And if you, one way to do it would be to immediately put it into the multi-sig wallet, but you don't have the step that allows your user to be very peaceful before actually sending it to multi-sig. So to help your users get better experience, as in get their peace of mind, you can actually add a simulation feature in here. So when you click the simulate button, what happens in the background, the app sends a request to Tenderly's simulation API. We simulate it against the latest data on the network that I've selected. And I think this was Goerli as well, but it may as well be mainnet. So it includes the data about your account's balance, the data about the state of the contract you're invoking here, and that's this contract over here, and so on and so on. So you can actually see if you're adding to your multi-sig the right things, or you're adding stuff that will break and just cost you time, energy, and money. So the next step would be to actually see how this simulation looks like. And you can see here that it looks absolutely the same as the previous thing we saw. So somebody wanted to join the game and wanted to join the game number 1. And you can, of course, explore why this is wrong. But let's not go there. We will do something to explore it. But before we do, let me just show you that little piece of code that does this. So I'm going to go into this file, and this is the function that gets triggered when somebody presses simulate. And as you can see, it just invokes. I even used fetch. It was that simple. I just invoked the simulate API, and the body was simply the transaction parameters, all that stuff that you've seen in the UI. And there are two ways. It either errored out, or there's a success, or there's something else, and you get the simulation URL. And the simulation URL is the thing that opened up Tenderly's dashboard, so your users can see and understand why their transaction failed, or if it succeeded, how it succeeded, what are the effects, before actually committing to putting it into the multi-sig wallet. So that's one way you can help your users do better, make better decisions and informed decisions before actually committing to doing something. Now, let's see how would it look if, so let's go into the role of the DApp user. So I tried this, it failed. So I must have messed up this data thing. So the function of this smart contract that I'm trying to call. And I haven't told you that this is actually the tic-tac-toe contract, and that this is actually attempt to join the game number 1. So if there is no game number 1, as we've just seen, what we can do is create a new game. So we're going to put in our multisig a transaction that will create a game for us. And to do so, let's simulate it from the scratch. I will hit new simulation, and I will use the tic-tac-toe contract, and I will select the new game function. And it doesn't matter who sent it. You can put Vitalik's address in here. You can put anybody's address, because this is a simulation. You can pretend to be anyone or anything you want. We will calculate it for you. And then I will hit simulate transaction. And what I get here is, again, everything the same. And I get the raw input that results in calling this function called new game. So I'm going to copy that, and I'm going to paste it here, and I'm going to hit simulate, and now it's green. So when I click open, I, as a user, have now an idea that, yes, this thing will go through when I put it into the multisig wallet, and it will call the function called new game. But before we go on, let's explore what Tenderly, what this thing actually brings us. So all of these things you see up here, they are here to help you analyze how your smart contract changed the state, how your transaction changed the state of smart contracts involved in it, including the ones involved via internal transactions. So the first thing would be to see events. And when you create a new game, you get a game created event, and it's nicely decoded. So you can actually see that the first field of this event is game ID, and the second field is creator, namely the address that I sent from. The second thing you can see is the state changes. So we can show actually what are the changes to the state of the contract. So it was 0 games, now it's 1. It was, so the games mapping actually got a new element, a new entry. So it's the game number 1, and the players are not initialized. The board is still empty, but you get the idea that something has changed. Of course, you have seen the debugger. So here we can, we might explore it in a different call soon. You also have a gas profiler that is showing that you have, that you actually see, you can actually see how much gas each of the functions in the entire call spent, and you can understand those and try to optimize them. And this is related to simulations, and I'm not going to go into those details now. But basically, you have the tools that allow you to see multiple aspects of your transactions execution, whether it's a real transaction on a network or a simulated transaction via the simulator. And let me recap what I did here. So the use case was I copied the raw input of calling new game. I pasted it here, I simulated, and then we got back into another simulation. I hope you didn't lose me there too much. So the next thing we can do, so now we're happy with our simulation, and let's go back into being the user. The user would be like, okay, I'm happy with this transaction. Let's send it to the multisig. And this UI is not responsive at all. So I'll just go into this fork over here. And you can see that there's a new transaction calling the submit transaction function, and I'll enter that. And you can see that it happened a few seconds ago, like when I pressed that button. So in this contract, you can actually see that a new transaction has been submitted by this owner. It's transaction number 7, and this is the call data. And if you recall, it's the thing creating a new game. All right, so this is a way that you can actually connect your front end to a Tenderly fork. So while developing this thing, and this thing that I'm showing needs way more development to be a better example, you can use actually forks so your UI can communicate with something that behaves like a network, looks like a network, but it runs really fast and enables fast iterations on the UI. Before hitting this button, I would like to go back into the front end code, and I will just show you. Yeah, this is not the one. So I'll just show you the way that you can actually achieve this. It's fairly simple. So on the one end, on the one end, we need the RPC URL of this fork. So as I said, forks expose RPC URL, same as networks. So you can copy it from the Tenderly dashboard. So it's this thing over here, and you simply create a provider using that RPC URL. So, so I just need to find it. Yeah, here it is. So this function, tx for multisig, the one that's called when I press add to multisig, what it does, it simply takes the contract, the multisig, and it sends, it actually invokes the send transaction. So this one ends up in there. And actually, sorry, this is me funding the multisig wallet. And this other thing is actually submitting transaction that other owners have to agree on. And this is the actual call that went to the Tenderly fork. And the last bit, I'm not going to explain it at all. So this button will run and actually confirm the transaction twice, and it will execute it. Now, to be sure that we're doing the right thing, because this UI is more like a hackathon submission, substandard one. So it's about transaction at index number 7. So I should copy index number 7 in here. And when I hit confirm, this transaction will be confirmed and ran twice, I hope. And let me just go back here, and we can see that we have confirm, confirm, execute. And when we go back in here, we can actually see that this one got executed and that it got, that we actually called the new game in multisig wallet source, but it originates from the tic-tac-toe game. All right, so that was a lot to process. So the key takeaway from this is that you can use the simulation API, so you can dry run your transactions before doing anything meaningful with them, so you can help your users make better informed decisions and reduce loss anxiety and stuff like that. And the second thing is you can use forks as you build your DApp as sort of a very speedy network, so you can iterate on your front end in a very, very fast way, and also get a chance to examine if something failed, why did it fail. It's again, this is all on the Tenderly platform, so anybody in your team can access a simple link of linking you to this transaction, so they could understand what went wrong, or if there's a bug to be fixed, and so on and so on. And I spent a lot of time here talking about forks and simulations, but I believe that it's a big feature that that can help you be more productive in doing your work, but also help you build apps, DApps with better user experience. So that much for this topic. And the last topic, oh, we covered 2 and 3 at the same go. All right. And the last topic is, well, can it get better? It's a bad name for what else is in the box. And this is the box. Actually, we have 3 boxes. Let me move this thing again, and let me turn on the slide. So we've seen forks, we've seen the debugger, we've seen the transaction simulator, and we've seen the gas profiler. So we have these 3 things going on in the area helping you develop and optimize your smart contracts in a good way. The second thing is about the observability. So it's about taking care of everything that needs to be taken care of, keeping an eye on important contracts, on alerts For example, a certain amount of funds got into your contract or out of the contract. So you can be timely notified when that sort of thing happens. Of course, incident management and analytics. And the third thing we have is the infrastructure 3.0, and that's where you have the simulation API. And I think that I will spare a couple of minutes about Web3 actions. So we actually have had a webinar about Web3 actions recently, and you can check it out on the YouTube channel. It's basically a way to build serverless JavaScript backends for your contracts. For example, when somebody joins a game, you can have a Web3 action listening and hooking into the events that smart contract emits. So new game event, you can hear about it, and you can run your custom code, send a notification somewhere, or do something like that. Of course, now imagine just instead of tic-tac-toe, replace that with DEX or another type of product you're building. And the third thing that recently that we released recently, I don't know if it's 1 or 2 weeks ago, lost in time, it's the Web3 Gateway. So it's a way to access blockchain and of course consume data and interact with blockchain in terms of actually sending transactions to your contracts, deploying new contracts and stuff like that. And it's sort of it's it's a testament to the way we build things, because to make all of these things possible, we decided to tear Ethereum virtual machine apart, glue it back in, but also extract a lot of information about how transactions execute. And we did similar thing with the Web3 Gateway. So we took a node, tore it apart, put it back together. But in the process of doing so, we sort of had we supported very, very fast read speeds. Some benchmarks we did show that compared to the average of the industry standard, it's like 8 times faster. And of course, there is also the multi-regional sort of aspect to it. Yeah, and that would be end of the slideshow. So I think I'm done 5 minutes early, and you can check out all this stuff on our website. You can also try to query the data from the blockchain from the dashboard itself. Let me just take a quick peek over there. At the moment, we support mainnet, Gorley, Sepolia. These two aren't supposed to be in the list any longer, but you get a way to actually do requests and see the data as it comes in. This is like the info about the latest block. And you can also check out the docs. We have some pieces on the development practices that are sort of that Tenderly tools help you achieve. So you can sort of see some ideas how to organize or improve your development process, but also how to improve your UX, how to enable staging of your DApps using forks, which is what we just did in this demo, for example, and so on. All right, so that's it for the demo. Now, Kevin, if we have any questions, I'll gladly answer those.
Oh, certainly. Thank you so much, Nenad. And yeah, if anybody has any questions, go ahead and jump in the chat. What a fantastic demo and workshop. I mean, you've really shown us the power of Tenderly. You've shown developers how it can make their lives easier, and how you can build faster, safer, and just better overall, which is really, really exciting to see.
Yeah. I'm very happy if I met that goal.
You certainly have.
Yeah. All right. So do we have any questions, maybe, or?
I think we're all set.
All set. All right.
Thank you so much, Nenad.
In that case, thank you guys. Keep having fun, and hope we see each other soon.
Indeed.